The carcass is still warm. An antelope, throat torn open, ribs cracked. 3 hyenas circle it, waiting for the lions to leave. And crouched in the tall grass, 40 feet away, is something smaller, slower, weaker, a hominin, one of your ancestors. He has no spear, no fire, no knife. Just a sharpened rock in his hand, and about 10 minutes before the hyenas decide he's not worth fighting for the leftovers. This is dinner, and dinner might kill him. So here's the question. Before fire, before a single flame ever cooked a single meal, what did your ancestors actually eat? And how, for millions of years, did they not simply die trying? The answer is stranger than you think. It involves raw meat rotting in the sun, insects eaten by the handful, bacteria your body no longer knows how to fight, and a digestive system so different from yours that if you tried eating like your ancestors for even 1 week, doctors would call it a medical emergency. Let's go back, all the way back. Here's something most people get wrong. They imagine cavemen sitting around a fire roasting meat on a stick. Cozy, simple, human. But here's the problem with that picture. Modern humans have existed for roughly 300,000 years. That sounds ancient. It isn't, not compared to what came before us. Our broader family tree, the genus Homo, stretches back nearly 3 million years. And fire? Real fire. Not the occasional lightning strike that burned a forest and moved on, but fire that hominins actually controlled, carried, and used every single day? That shows up somewhere between 400,000 and 1 million years ago. Some evidence hints at earlier flickers of it, but scientists still argue about how real and how routine that early use actually was. Do the math for a second. If human evolution were compressed into a single 24-hour day, fire wouldn't appear until nearly 11 p.m. That means for almost the entire day, for millions of years, generation after generation after generation, nobody cooked anything, not once. So what were they eating? Buckle in. It's worse and more impressive than you'd guess. Back to our hominin in the grass. He's not hunting because he wants to. He's hunting because starvation is patient, and it is always somewhere behind him. Here's the twist most documentaries skip. He probably didn't kill that antelope himself. For a huge stretch of early hominin history, scientists believe scavenging, stealing kills from other predators, or picking apart what they left behind, was just as important as hunting, maybe more important, which means the meat on the menu wasn't always fresh. Sometimes it had been sitting in the African sun for hours, sometimes longer. And here's the detail that should make your stomach turn. Hyenas and vultures eat meat that's already deep into decomposition, and they're fine. Your ancestors were doing something disturbingly close to the same thing, raw, sometimes rotting, and they ate it anyway. Why? Because the alternative was worse. Now here's where it gets physical. Try this. Imagine biting into a piece of raw meat right now. Not seared, not marinated, just raw muscle straight off the bone. You'd chew and chew and chew. Your jaw would start aching before you'd swallowed a single bite. Now imagine doing that for every meal, every day, for your entire life. That was normal. Raw meat is tough, mechanically brutal actually. The muscle fibers, the connective tissue, the cartilage, none of it has been softened by heat. Cooking breaks down collagen and loosens muscle structure. Without cooking, your ancestors' jaws had to do that work instead. This is why early hominin skulls look almost frightening compared to ours. Massive jaw muscles, huge molars built like grinding stones. Not because they were primitive, because their food fought back every single time they tried to eat it. But the jaw wasn't the real danger. The real danger was invisible. Here's a question that should worry you a little. If raw meat carries salmonella, listeria, and a long list of parasites, the exact reasons modern food safety laws exist, how did an entire species survive eating it, raw, for millions of years? For a long time, this genuinely puzzled researchers. The answer scientists eventually landed on involves something inside your own body, right now, that you've probably never thought about: stomach acid. Human stomach acid is unusually aggressive. More aggressive than it strictly needs to be for the cooked, sanitized diet most of us eat today. That extra strength appears to be a leftover weapon, a defense system built during millions of years of eating things that should, by all rights, have made our ancestors sick. And here's the part that doesn't make it into most retellings. It didn't always work. Hominins almost certainly got sick. A lot. Some almost certainly died from exactly the kind of food poisoning your body is built to shrug off today. Illness from raw food wasn't an occasional risk. It was baked into daily life, one more danger in a world already full of them. They ate anyway, because eating nothing was a guaranteed death, and eating something dangerous was only a possible one. That single trade-off sums up an entire era of human history. Not all meat was created equal, though, and your ancestors knew exactly which part they wanted most. Not the muscle, not the tough stuff that took 10 minutes of jaw-breaking effort per bite. The marrow. Crack open a long bone and inside is a soft, fatty, calorie-dense core. Easy to eat raw, packed with energy. Archaeologists have found ancient animal bones covered in very specific damage, percussion marks from stone tools made for one purpose only, smashing bones open to get at the marrow inside. Think about that for a second. Before your ancestors had fire, before they had language as we know it, they had already figured out this is the good part. That's not luck, that's strategy, and it's the first clue to something bigger we'll come back to later. Because marrow wasn't just food. It might have helped build something you're using right now to read this sentence, but meat was only half the story. Picture a completely different scene. No carcass, no hyenas, just a woman on her knees, digging into dry earth with a sharpened stick, pulling out a starchy root the size of her fist. She's found calories, actual, reliable calories, except there's a catch almost nobody talks about. Raw starch, the kind found in tubers and roots, is locked inside a tight crystalline structure. Human digestive enzymes struggle to break into it. Cooking would eventually solve this completely. Heat and water swell the starch open, exposing it fully to digestion. But without fire, a meaningful portion of that calorie-rich root would pass straight through the body, undigested, wasted. This left researchers with a genuine puzzle. If raw tubers were this inefficient, how did early hominins get enough energy from plants at all? They found workarounds. Pounding and mashing the root increased surface area. Fermentation, sometimes accidental, food just sitting in the heat, softened it further, and most importantly, hominins likely leaned harder on foods that didn't have this problem at all. Ripe fruit, already sweet and directly absorbable, and nuts and seeds, dense in fat and protein, no cooking required. So picture the real pre-fire plate. Less starchy potato, more fruit, nuts, and leaves, with tubers as a fallback, not a favorite. And then there's the food source almost nobody expects. Termites, ants, grubs, beetle larvae. Here's the thing, insects didn't need to be cooked to be good food. They were already soft, already digestible, already packed with fat and protein. No processing, no risk from crystalline starch. Just food, walking around, available almost year-round. Watch a modern chimpanzee, our closest living relative, and you'll see this behavior happening today. Chimps strip leaves off sticks, poke them into termite mounds, and pull out a snack. It's not primitive, it's engineering. And then there was honey, pure concentrated calories, ready to eat with zero preparation. The only problem? Getting it. Wild bees do not share. Which means somewhere back in that timeline, a hominin looked at a tree buzzing with angry insects and thought, worth it. He was right, it usually was. But all of this, the meat, the tubers, the insects, the honey, was leading somewhere much bigger than dinner. Here's where the story stops being about food and starts being about you. Compare a human gut to that of a chimpanzee, relative to body size. Ours is noticeably smaller, especially the colon. For a long time, that seemed like a strange design flaw. Why would evolution shrink something so important? Then researchers Leslie Aiello and Peter Wheeler proposed an answer that changed how we think about human evolution entirely. It's called the expensive tissue hypothesis, and the logic is almost eerie in how elegant it is. A large gut is expensive to run. It burns enormous amounts of energy just existing. So does a large brain. Your body can't easily afford both at full size. But once cooking began pre-digesting food, breaking down starch, softening meat, killing pathogens before they even entered the body, the gut no longer needed to work so hard. It could shrink, and the energy that used to go into running a massive ape-like digestive system, it got freed up for something else, the brain. Read that again. The theory suggests that cooking may not have just changed what your ancestors ate, it may have helped make room, metabolically, for the exact organ you're using to understand this sentence right now. Which raises an uncomfortable question about the era we've been describing this whole time, the pre-fire era. If this theory holds, hominins who hadn't discovered cooking yet were stuck. Bigger guts, tighter energy budgets, a harder ceiling on how large their brains could grow. They weren't just eating differently. They were evolving under different rules entirely. Here's how scientists know all of this isn't just a good story. They look at teeth, specifically at microwear, microscopic scratches and pits invisible to the naked eye, caused by exactly what an animal was chewing before it died. Early hominin fossils are covered in it, and the wear patterns don't lie. They show relentless mechanical stress, tough, fibrous, unprocessed raw food, chewed for years, leaving its signature behind like a fingerprint. But not every hominin species shows the same pattern. Some, like Paranthropus, developed jaws and teeth built like industrial machinery, enormous, specialized, clearly adapted for grinding through tough, fibrous plant material almost exclusively. Others, including the branch that eventually led to you, show something different. Less extreme specialization, more flexibility, teeth built not for one food, but for whatever was available that week. That flexibility is the whole story in miniature. The hominins who survived long-term weren't the strongest, fastest, or best armed against predators. They weren't even the best chewers. They were the ones who could adapt, who could switch from meat to tubers to insects to fruit, depending on the season, the location, and sheer luck. Which brings up an interesting modern experiment. Here's a question worth sitting with. What happens to a modern human who tries to eat the way your ancestors did, mostly or entirely raw? It's actually been studied. People who follow strict long-term raw food diets today show measurably lower body mass, and in women specifically, higher rates of missed menstrual cycles, a sign the body isn't getting enough usable energy. In other words, this isn't some secretly superior natural way of eating that modern life ruined. It was hard, genuinely, physically hard. Your ancestors didn't choose it because it was optimal, they endured it because it was the only option they had. And it wasn't just about food. There was another threat hiding in something even more basic. Here's something easy to forget. Fire didn't just change eating, it changed drinking. Boiling water kills the vast majority of dangerous pathogens, bacteria, parasites, protozoa, lurking in rivers, ponds, and streams. Before fire, none of that protection existed. Every drink from a natural water source was a gamble. Bad water didn't announce itself. It looked exactly like good water, right up until it made you sick. So hominins had to learn, the hard way, generation after generation, which sources were usually safe and which ones weren't. That knowledge had to be remembered, shared, passed down. Get it wrong and it could cost you everything. This wasn't a footnote to survival, it was survival. Food and water both requiring the same kind of hard-won, accumulated knowledge that no single individual could have figured out alone. Which brings us to something unexpected. The kill itself created a problem nobody planned for. Say your ancestor actually lands a kill, a big one, more meat than one person could possibly eat. Great news, right? Not exactly. Without fire, there's no smoking, no drying, no real way to preserve it. In the African heat, that meat starts rotting almost immediately, which means there's really only one option: eat it fast or share it fast. And that pressure, as strange as it sounds, may have quietly shaped human society itself. If meat can't be saved, the smartest move isn't hoarding it. It's spreading it around the group immediately, before it spoils, in exchange for the unspoken promise that when someone else gets lucky, they'll do the same for you. Anthropologists see this exact behavior in modern hunter-gatherer groups today. Wide, reciprocal meat sharing woven deep into the culture. And the evidence suggests the roots of it go back further than anyone expected. Further than fire, further than cooking, back to a simple, brutal fact. Rotting meat forces generosity, or it forces waste. And generosity, it turns out, builds relationships that keep you alive later. Not every food had this problem, though. Nuts and seeds had something meat never could: patience. Low moisture, tough shells. They could sit for weeks, sometimes months, without spoiling. A natural pantry, no technology required. Tubers had their own trick. Some varieties simply stayed alive underground, dormant, waiting. A hominin didn't need to preserve them at all, just leave them in the ground and come back later, like a savings account buried in the dirt. Piece by piece, a picture starts forming. This wasn't chaos. It was strategy, different food categories, each managed differently, each solving a different problem, stitched together into something that looks a lot like a plan. And we don't have to guess at all of this. We can watch a living relative do something remarkably close to it, right now. Chimpanzees are the closest thing we have to a window into this world. No fire, no cooking, still surviving. And what researchers have documented over decades of watching wild chimp populations is startling. Over 100 different plant species eaten at some sites. Sophisticated insect foraging using tools. Opportunistic meat taken through both scavenging and active hunting. Active hunting. Chimpanzees have been filmed coordinating group hunts, actual role division among hunters, chasing down monkeys through the trees, and afterward, sharing the meat among the group in patterns that look almost eerily human. No fire, no spears. No language as we'd define it. If chimpanzees can pull that off, it puts an old debate to rest. Were early hominins passive scavengers waiting for scraps, or capable hunters in their own right? The honest answer? Probably both, shifting depending on the animal, the season, the location, the moment. Not one strategy, a whole toolkit of them. Which finally brings us back to where we started. Remember him? Crouched in the tall grass, 10 minutes on the clock, a sharpened rock in his hand? He's not just hungry, he's carrying, without knowing it, the accumulated pressure of millions of years of exactly this decision: meat or no meat, risk or starvation, now or never. He doesn't have fire, he doesn't need it yet. What he has is something harder to see and far more important: the willingness to eat something dangerous, chew something exhausting, remember which water didn't make him sick last time, and share the meat if he's lucky enough to get it. Because someday he'll need someone to share with him. That willingness, not strength, not speed, not sharp teeth, is what carried an entire lineage across millions of years of raw, unforgiving, uncooked survival. By the time fire finally arrived, it didn't create human intelligence from nothing. It walked into a species that had already spent millions of years being tested: one raw meal, one cracked bone, one dangerous river, one shared carcass at a time, and simply gave that species room to grow further than raw food alone ever could. So the next time you sit down to eat something that took 30 seconds in a microwave, remember what that convenience actually replaced. Not laziness, not simplicity. Millions of years of your ancestors' teeth, guts, and stomach acid, quietly evolving, just so that one day you wouldn't have to fight for it.